Alright, so today we are actually trying a different program to do our videos, and this time I'll be narrating over a PowerPoint that I had made before to teach variables. So in class you guys can let me know what you prefer. We'll try this a few times and see what we think. So we're just going to review a few examples of how to identify these variables. So just to recap, a variable is anything that can change in an experiment. And so on the left side, first we have an independent variable, and another word for that is manipulated. And this is what you're in charge of changing in the experiment. So one of the ways that you can remember is that you can tell yourself this is what I change in an experiment, and the I goes with the I in independent. The dependent variable is the same thing as the responding variable. This is what changes as a result of the independent variable, and that's what IV stands for. Don't confuse that with the Roman numeral 4. Finally, we have the constant, and that is anything in the experiment that you keep the same. And so typically this is going to be everything when you're setting up the experiment aside from the independent variable, so you can see what changes because of what you're doing. So I know during an experiment it might seem like it's a waste of time to do multiple trials, and we just need to remember it is important to do several trials for each variable in your experiment. For one thing, because there's always that human error factor where you might, for instance, you're working with a stopwatch and you accidentally hit the button at the wrong time. And so it's a good idea to do several trials to make sure that you didn't make a mistake in your measurements that you're making. This is also to verify data. Another way to say that is just to ask yourself, is what I'm measuring accurate? Does it make sense? And so if you do several trials and the numbers all seem to match up, you're probably getting accurate information. So when we're doing experiments, it's important to have a group set aside, and it's known as the control group. And this is one of the trials in the experiment where you don't change any of the variables at all. And this can be used for comparison later to see if anything does change as a result of what you're trying to change in the experiment. And so throughout the year you'll have lots of practice with this, and you'll get to really understand the importance of having a control group. So on your notes you have several scenarios set aside for us to take a look at. This first scenario is Janice's toy shop and the caffeine dilemma. So just read on your paper. I'm just going to read this out loud to you. It says, Janice owns a toy shop. She thinks that giving her employees caffeine will make them construct the toys more quickly. Janice divides her employees into two groups of 20. She gives caffeine to Group A. She doesn't give caffeine to Group B. At the end of an hour, she found that Group A constructed 100 toys and Group B constructed 150 toys. Then you're having to identify the variables in her experiment. Well, the independent variable is what she's in charge of changing. So in this case, she purposefully gave caffeine to Group A. Therefore, that is the independent variable. So that's what you'll be filling in your blank. The dependent variable is what she was expecting to change as a result of her manipulation. So she manipulated the caffeine, and she was expecting to see a difference in how many toys were constructed based on which group got the caffeine, which group didn't. The things she had to keep the same. She wanted to have the same number of employees in one group and another. She didn't want to give one group an unfair advantage. She also made them construct the same type of toy, and they also were given the same time to make those toys. So they had the same conditions between the two groups, except the fact that one got caffeine and one didn't. So her control group, she had one group that did have the normal conditions for the working environment, and in this case the control group is Group B because they did not get caffeine. And typically the boss isn't going to walk around handing caffeine to everyone so that they're more productive. So that's why that's the control group. Our second scenario involves Bill and chocolate chip cookies. And I've got to be honest, this is probably my favorite one on this paper because it involves some yummy food. So this is my kind of experiment. It says that Bill loves his grandmother's chocolate chip cookies. He would like more chocolate chips in the cookies. Who wouldn't? But he's not sure if more chips would change the crunchy texture of these cookies. He'll need to do an experiment. That's the best reason to do one. So you have to identify the variables. Well, here he's wanting to play around with how many chocolate chips are in the cookies, so that would be considered the independent variable. So based on how many chocolate chips are in the cookies, he's wondering how that's going to change the texture. So the cookie texture is the dependent variable. The texture depends on how many chocolate chips there are, so he thinks. So everything else is what you need to keep constant. You need to keep the recipe constant. Everything involving the recipe, like oven temperature, baking time, whatever other ingredients are necessary to make these cookies, all of that needs to stay the same. The only thing that changes is the amount of chocolate chips that Bill adds. A control group, it's always a good reason to make more cookies. So a control group might be cookies with no chips at all. So he can compare how crunchy those chocolate chips make the cookies as he adds more to them. Finally, we come to scenario number 3. I know this slide says number 1. That's because I can't type. So on your paper it does say scenario 3, and this involves Susie Q and some plant lights. So Susie Q wants to know the effect of different colors of light on the growth of plants. She believes that plants can survive best in white light. So she buys 5 ferns of the same species, which are all approximately the same age and height. She places 1 in white light, 1 in blue light, 1 in green light, 1 in red light, and 1 in the closet. All of the ferns are planted in Miracle-Gro and are given 20 milliliters of water once a day for 2 weeks. After that 2 weeks is up, Susie observes the plants and makes measurements. So the thing that she's manipulating, what she is controlling here herself, is she's in charge of changing the different colors of plant light. So that is why it's the independent variable. So as a result of the different lights, she's expecting the plant growth to change after 2 weeks. That's why that is the dependent variable. For the constant, she's keeping everything about the plants the same other than that. So the type and age of the plants, their initial heights, the soil that they're planted in, amount of water they're given, the time to grow, all of these things that would enable the plant to grow have to stay the same aside from the light that they're put under. Finally, she does have a control group to compare the light growth to, and that would be the plant that's put in the closet. So she'll be able to compare all of their growths to that. So now that we have done these examples together, you do have a question to answer that is posted above this on Edmodo. So please try to go ahead and get that submitted. And if you don't get a chance to do that for whatever reason, please come either during homeroom tomorrow morning or we'll get it taken care of at the beginning of class. Thanks for being patient with me about getting this put up, and I hope you have a great night. I'll see you tomorrow.